Hey everyone, welcome back, and in this video let's talk about the four pillars of object orientation programming. Okay, now what is object oriented programming? You already know that. Now let's discuss the four pillars, basically four main pillars of object oriented programming. So these four pillars are abstraction, encapsulation, inheritance, and polymorphism. Now in this video I'll be giving you an overview and a theoretical answer to abstraction, encapsulation, inheritance, and polymorphism, and from next video onwards we'll be coding them one by one and understanding them better with code. Okay, so let's start with our first pillar, that is abstraction. Okay, so in order to explain abstraction, let's take an example. Now I guess that you all have you know that how to drive a car. Okay, so you have a car, correct? Now a car basically has three pedals, correct? One pedal is clutch, then you have brake, and then you have a escalator, right? A race. Now what happens when you press this button? Okay, when you press this pedal, the car speeds up. Okay, when you press this particular pedal, the car stops. And when you press this particular pedal, now you have the ability to change the gear, correct? But there, what happens, like if I talk about you, like what is the internal implementation of clutch, like what exactly happens when you press the clutch? So you will say, I don't know, like there is something, I don't know what is the system, but yes, when I press the clutch I can change the gear, but what happens on the internal side, I don't know. Similarly, when you say that I press brake and my car stops, now what happens on the back end or what happens internally in the mechanics, I don't know. And same goes for the race, correct? And similarly, let's say that a most common example, in your house you have a switchboard, correct? You have a switchboard in which you have many switches, right? And you have a regulator. Now when you press this switch, what happens? Basically your lights turn off. When you press this switch, let's say your fan turn on, and when you press this switch, let's say your TV turns on, and this regulator can control the speed of your fan, which is absolutely correct. But if I ask you, like what company, how wiring is done, which wire is going through where, you don't know about that, correct? So that is all magical, that is all black boxed and hidden to you, correct? So you know that only what you should know, correct? So abstraction basically means hiding the internal implementation and showing essential data. In both of these examples, you are only exposed to some essential details, right? Here pedals are exposed to you and here buttons are exposed to you. But the internal implementation of these both things are hidden. So that's the meaning of abstraction. So basically, in coding terms, what you say is, whenever you write a code in object-oriented programming way, so what you can do is you can basically abstract the logic. Okay, you can basically abstract the things and basically move the public, like using the public access modifier, you can only expose essential details out. Like we have seen in the previous video, I abstracted the name and the age from the user because user don't need that, and I only expose the essential details, for example set name, get name. So that is the first pillar, that is abstraction. So OOPS provides you an abstraction with which you can hide the internal implementation of things and expose the important things, or I can say essential things, to the user. So that was our first pillar. Second comes encapsulation. Now you already know what is encapsulation basically. So we have already seen that we have a person class, let's say we have an animal class. So what we were doing is, all the properties and all the methods that were related to person, we were encapsulating it inside a person class. Similarly, all the properties and all the methods that belongs to an animal, we were encapsulating them inside the animal class. Okay. If we don't have object oriented programming style or design, so what will happen is we'll be having function for each one of them, and it will be really difficult for us to encapsulate them. We'll get confused in some point of time that which function belongs to what. So object oriented provides you with something known as encapsulation, in which you can bind, you can encapsulate your methods and the properties inside a class. So as the name says, encapsulation, basically encapsulation, like capsulizing the methods and the properties inside a class. Okay, Then comes the inheritance. Okay, now what is inheritance? Okay, now this is really interesting. Let's say that this particular guy, this particular person is your father. Okay, okay, so this particular person is your father. Now your father basically has some properties, like he has a height, right? He has some genetics, he has some, let's say, eyes color and more other properties. Now this is you, basically you are son of your father. So there are chances that most of the properties of your father will be same to you, right? If your father has a tall height, you will be having a tall height. If your father has green eyes, there are chances that you will be having a green eyes as well, correct? So this is what you know now, this is what is called as inheritance, correct? Now the inheritance is a generic term, but what it has to do with OOPS, okay? So you'll understand. In OOPS, basically what happens, you can inherit the properties from one class to another. Okay, how? What we can have is, we can have a parent class. Let's take a classic example. Okay, let's say we have a car. Okay, now a car is a class which we know. Okay, and car can have some method, that is, like we can have a start engine method. Okay, now we have different brands, like we have Kia, we have Honda, correct, and let's say we have maybe Mahindra. Okay, so these are some popular brands, correct? Now see, now can I say that the start engine function of the Kia brand would be a little bit different, the Honda would be a little bit different, and for Mahindra it will be a little bit different. So what we can do is, we can basically inherit the car class in all three of them, and we can modify them a little bit. Okay, so with inheritance, basically what I did, I reused this function, this start engine function. Okay, let me change the color. So I reused this particular function and modified a little bit according to the child class. So this particular thing, this car is known as parent, and the Kia, Honda and Mahindra are basically inheriting the parent class, the properties of the parent class, and then modifying them a little bit. So that's what is known as inheritance. And the benefit of inheritance is basically reusability of the code. So if the parent has like 100 features, so all the features will be reused in the child class, and you can override few of them, right? So that is the benefit of inheritance. And OOPS basically provides inheritance as well. So that was our third pillar. And on the last, we have a polymorphism. Okay, so basic meaning of polymorphism is many types. Okay, polymorphism basically means many types. Okay, when there are more types of a similar thing, we call that as polymorphism. Let's say, okay, a classic example, your father, okay, this person is your father. Okay, this person is son to someone, this person is like grandfather to someone, and this person is maybe boss to someone, correct? So can I say that this particular person has many forms depending upon where he is? So this is known as polymorphism, having many forms. In code, we have already seen an example of the plus symbol. If I say 3 plus 2, what will happen? I'll be getting 5. So this plus operator, basically what it did, it sums up the two numbers, which is correct. What if I say Piyush, okay, plus Garg? Now what will be the output? So obviously you cannot add strings mathematically. So the output will be Piyush Garg. So what this plus operator did is basically concatenated, joined two strings. So this plus operator performed differently here, and this plus operator performed differently with strings. So this is known as polymorphism, and in object-oriented programming design, it really makes the polymorphism easy. Okay, so can I say that here the start engine has many types? Okay, it is performing differently for Honda and differently for Kia and differently for Mahindra. So these were the theoretical overview of the 4 pillars: abstraction, hiding the internal implementation and showing the essential information to the user; encapsulation, basically binding or encapsulating the methods and the properties inside one class. Then we have inheritance, inheriting the properties from the parent class, which makes our code reusable. And polymorphism basically means having more than one type, having many types. So these were the 4 pillars of Java, and in the next video we'll be coding them one by one to better understand them. So that's it for this video, and let's meet you in the next video. Until then, bye bye, take care.